Hi everyone, in this video I will show you how to make this multi-directional blink effect. So here, using the gamepad or the keyboard, I can blink in any direction I want. So I can blink forward, backward, left, right, and in diagonal directions like this. So here you can see when I blink, there is like a preview effect on the place I am going to be spawning, and also there is some beams connecting the two locations and some particle system flying around. And here it will automatically calculate the distance you can blink. So if I blink from here, it will stop here, and if I blink from here, it will stop here. So no matter how close or far you are from something, it will automatically calculate where the blink ends and begins. And it can also blink up hills, down, etc. And here you can see this green colored wall. So here I have added a pass through tag to it, an actor tag, and if I blink from here, you can see that I can blink through it like this. And here you can see this red rectangle. So here I cannot blink on it, so I will just stop at this location, but I can blink from it, but I cannot blink on it. So if I blink from here, I can blink across it, but if I try to blink from here, I will stop like that. And you can blink on inclines, and you won't really end up inside any mesh when you blink. So it's a smart system, and you can also do a lot of stuff. So with this tutorial, you will get this actor component and like this one function that you can call from your character. So you can add this to any character you want. So you can just type in AC blink into any character, and you can just add that to any character you have made. So if I select this, you can see that I can set the blink distance. So here I will just set this to like 1000, and here I can change the blink delay. Here I can change all the effects, and here I can just change the color if I want. So I can give a green color to it. And now if I select this and type in tag here, you can see that there's a blink pass through tag on it. So if I just copy this, and if I go here and if I just paste this, you can add this tag to any actor in the world. So now if I just blink from here, you can see that I can blink through it. And here you can see that the color has also changed like this. I can also change the blink delay to like 6 seconds, 6 milliseconds. So if I blink, you get an effect like this. Or I can set this to like 0.1, so it will be really fast. And with this, the debugging is also really easy. So if I just set this to like for duration, I can see the line trace. So here now I can see the line trace it is using to blink to the location. And here you can see we are blinking through it. And if I try to blink here, or here, you can see where it cannot blink and where it can blink like this. So you can also set the distance, angle, etc. of this line trace also. And here I have created this AI that has a different blink effect that kind of chooses a random location and blinks to that location. So if you want to download the entire project file, including the blink effect, this one, and also the AI blink effect, you can support me on my Patreon. So if you want to get these two effects, and also almost all my project files from my previous tutorials, you can support me on my Patreon. And for $5, you can download all of these from there. And if you are already my patron, thank you very much for supporting me and this channel. You make all of this possible. Thank you. This video was sponsored by Wingfox. Wingfox is a site where you can learn a lot of CG stuff. There are a lot of courses on CG, VFX, game art, graphic design, animation, etc. And on this website, you can find a lot of cool Unreal Engine courses. So one course I really want to recommend to all of you is this Mastering UI Development in Unreal Engine 5 course. So this is a really long course where you can create Genshin Impact like UI that you are seeing here. So this isn't just a pure user interface tutorial. In this, you will learn how to use blueprints, Niagara, systems, materials, UI, etc. to create this cool looking effect from Genshin Impact. You will learn the blueprint, the Niagara and the particle systems to do all of this. So it will start like this and you can end up with something like this. So this course is done by these three guys, Mauricio, Ramanand and Andre. So this is a really cool course. So this is like a 15-hour course with 83 lessons and I'm sure you will learn a lot of things from this. So UI is one of the things I struggle with and this tutorial has a lot of contents in it that is really interesting. So if you want to purchase this tutorial, you can use the link in the description below and use the code WFM15 to get 15% off on most of the courses from Wingfox. And thank you very much to Wingfox to giving me access to this tutorial and also sponsoring this video. So check the course out from the link in the description below. And don't forget to use the code WFM15. Now in order to make this effect, first we will create the actor component. So we have something in place for the blinking. And then we will create the Niagara particle system. And after that we will refine our blueprint. So right click, blueprint class, and here click actor component. And we can call this AC, blink and YT. So if you have a lot of actor components, you don't really have to create a new one for it. You can use something that is already there. So now open this up. So here I will right click and type in custom event and I will call this blink start. And here we need to teleport the character to a new location. So in order to do that, we can go to the event begin play and here we can get a sequence node. So we get this different outputs from here. In the first one, we can just do get owner. So this will get the owner of this component. So if you add the component to a blueprint class, then the owner will be that class. So in this case, the owner of this AC blink is the character blueprint. We can also add the one we created. So AC blink YT. So this is the new component we created. So here we can type in cast to character. So this is very important that we don't really cast to the third person character. We can also cast to third person character from here, but we don't really want a hard reference because if you are already working on some games and if you want to add this actor component to that project, this third person character maybe won't be there or the third person character will be different. So we don't really want a hard reference to the third person character, but we just want like a soft reference to the character class. So things that generally wants to blink is like a character class that has a movement component, capsule component, etc. So that's what we want. And we can just store this reference to a variable. So we don't really want to do a function call every time we want to access the character. Now here we can just drag this and type in get world location. So we can get the world location of the capsule component. You can also initialize the capsule component here also. You can just get that from here and create that into a variable, but we are just going to get it like this. And here we can get the world location. Now get forward vector. This is just for testing for now. Later we will create the complicated blueprint. So here we are just going to drag from the capsule component and type in set world location, and here we will add the world location with a value that we can get from the forward vector and also multiply that with the float. So change this to float and promote this to variable, and we can call this distance. I think I will call this blink distance. So forward vector is just a unit vector that points in the direction in which the capsule component is facing in the x direction. So we can blink a distance of 500, and we can just connect this here and connect this here. And for now, we will just click teleport, and we can go here and we can drag in our AC control. And now here you can type in shift. So left shift, or if you have a gamepad, we can type in face button right. Now here we can drag this and type in call. So blink start. So we can connect both of them here. And now if I just press play, and if I press the button we just assigned, you can see that I'm just blinking forward like this. So here, if I just blink from here, I will end up here like this. So if you don't want to go through the mesh, we can just go here and click sweep and untick teleport. So now if I just go here and press this, I won't move. And if I press from here, I will get stuck here. So for now, this is all we want. And later we will improve our blueprint. So now we will create our Niagara systems. So right click, then go to FX, then go to Niagara system and click next. And now click on the confetti. And now I will call this NS start. So this is the start blink effect. And we can go in here and here. For this color, we can go here and type in color and linear color, and we can call this color 1. And now we can give this orange color here. So these values, and I will just drag this in. So with this, it will be easy to control all the colors. And here it is not appearing on the confetti because of this material. We can just click here and type in default bright material. So we get this effect. Now if you want a darker effect, if I just copy paste this, and if I just change this color to black, it won't really show up since this material is additive and it won't show up. So a black material, we can just go to the starter content and we can go to the particles, then materials. So in order to get a darker color, we can go to the M radial ramp. If I open this up, this is a really simple material, but this is translucent. We don't really need translucent for our darker material. If you want the translucency, you can use it, but I'm just going to duplicate this and I'm just going to create a masked material. So I will just rename this masked, and here we don't really need the power. Connect this directly, and here change this to masked and connect this to opacity mask. So we get a really bright white dot like this. Now click apply. Now we can add this here. Now we also have some black spots. Now change the amount to like 30 and 20. For the black one, we will increase the size to like 3 and 8, maybe 3 and 6. And here we can change the shape to like 4 and 4. So the area will be smaller. So here we get this explosion effect. And now we need a bright spot in the middle. And for that, we can add an emitter. And we can go to single looping particle. And here we can go to the emitter update and change the life cycle mode to self. So it will only spawn once, and change the loop mode to fixed and duration to 1 second. Maybe like 0.5 seconds. And then go to the initialize. And we only want this to remain for like 0.2 seconds or something like that. So just undo this and change this to like 0.3. And here we can go to the color mode and go to direct set. So this will allow us to set the color, and we can just drag our color in. So when I change this, everything will change with it. So it will be easier. And for the material, we will change the size to like 5. So here we have this bright spot and some particles spawning like this. So now we can add this to our blueprint and see how it looks like. We can go to the blink, and here I will just do spawn system and location, and here I will just spawn it at the current location of the capsule, and here I will just select the system we just created. So it is this one. So I will just add this, and if I just press play and if I press the button, so now here you can see the effect happening like this. Here if I just use a delay, and here I can go to the system again, and I can just duplicate this, and I can call this ns end, and if I just duplicate this and add it like this and add that, and for this one we can just get the new location. Remember, we will improve the blueprint later, so it won't look anything like this. This is just to preview the particle system right now. So now, after a small delay, this particle will be spawned at the capsule location. So now if I press play, we get this effect. Now we will work on the middle effect, but keep in mind that this end effect and the start effect right now is just for preview, and later we will fix them and make them look a bit better. So now just duplicate the ns start, and I will call this ns middle, then open it up, and here we don't really need the confetti, so I'll just disable it and move it back like this. And now right click, add emitter, and we can add this hanging particle, and here we can go to the initialize particle, and we can set our color first like this. So we get this particle spread around like this. Now we can go to the shape location and change this to sphere and change the radius to like 200. So we get something like this. And now we can go to the emitter state and change the loop behavior to like once, and we only need to do it for 0.5 seconds, and the lifetime should also be set to direct set, and also the value should be 0.5. So it will appear fast and disappear, just like how I demoed it. Now here we don't really need this wind force, this aerodynamic drag, this scale bright color. We don't really want that. Now this scale color, this we also really don't need. Now we need to attract this to the center. So for that, click this and type in point force, point attraction force, then click that and set this value to like 1600 and the attraction radius to like 900, or maybe we can set this to like 2000. So everything kind of gets into the middle like this. So everything gets attracted to the middle like this, and we can also increase the kill radius, so it will get killed when it reaches the center. So I can set this to like 9 or something like that, so it gets destroyed. Now here we need to make it more visible, so for that we can set the size to like 12 and 22. So now we get this. Now we need to stretch this in the direction of the velocity. So for that we can go to the sprite render, and here the alignment we can change this to velocity aligned, so it looks weird like this. To fix that we can go to particle update and click this and type in scale velocity or scale by speed. So here we have this scale sprite size by speed. Click that, and here I will set this value to like 0.5. This will be 1, and this value should be like 10 and 20, or like 10 and 15, and maybe set this value to like 0.3 and this to like 0.2. Okay, so a better value might be like 5 and 8. So now it is getting attracted to the center. I can increase the spawn rate to like 100 and then duplicate this. Now here we also need the black color, but we cannot add that because this is an additive material. So we can get the material we created earlier, this M radial masked here. So I will just add that here, M radial masked. So this one, and I'll just untick this and change this to black. You can also change the material here to that also if you want, but it is fine like this. I will increase the spawn rate. For the black one, I think we should just decrease the spawn rate to like 60. And maybe we can increase the size a little bit like this. And here we can set the sprite size of this single particle to 10. So you can see it in the middle. And now we can just duplicate this. Now here we can add like a glow effect. So after this, I will just rename this to glow. And for the material, I will just go to the starter content, particles. So here we have this M flare. I will just add that here like this. And here I will increase the size to like 100. So here you can see that the glow is a little bit too much. So in order to fix that, we can go here and type in value and hue shift linear color. So here I will just drag in the color to the linear color. And for the value, I will give a value of 0.1 or 0.01. So you can see there's a subtle glow effect like that. Maybe we can increase the size also to like 200 like this. So we have a glow effect. So this particle, we can increase the size to like 40 or maybe like 20. So we have this glow effect. Now we can give both of these some jitter. So jitter, and the values can be like 5. And here also we can add a jitter. So you can add jitter a bit and maybe increase the spawn rate to like 200. So if you want to, you can also set this to like GPU if you want to spawn a lot more. But I'm just going to set this to like a CPU for now. Now we can give a ring that shrinks down to the center. So for that, we can get this single looping particle again and we can just paste it. And here, I will set this value to like 300. So it will be really big, or like 500. And here I will go to the particle update and type in scale, sprite size, scale. And now here I will go to the particle update and type in scale, sprite size. And we need to reverse this. So set this value at time equal to 0 to 1. And this one at time equal to 1 to 0. And now we can select both these points and auto curve it. So it will be a little bit more smoother and looks better. And here we can just bring it up like this, maybe down a little bit like this. And we can change the lifetime to like 0.1 or like 0.2. So it will be faster. And here for this material, we don't really want to use this material. There is one more material we can use. You can use the M burst material. So open this up. This is a fairly simple material. So here it looks like this. So it is a circle. So here you can see if I open this up, if I just untick the green and the blue channel, you can see that it is just a circle. And if I just tick the green, you can see this effect. And if I just tick the blue channel, you can see this. So different values are stored in different channels. So because of that, when we break it apart, we get this circle and these two effects. And with this dynamic parameter, if I just set this to like 0.5 or something like that, then you can see that it kind of lurks in all the green and the blue channel also. So that's what is happening here. We will use the scaling in so that we will make this part appear at different location whenever particle plays. And other than that, this is a fairly simple material. It is just giving the particle color to the MC color. And here it is also additive, which doesn't really matter for us. And here it is clamped. So these values don't go above 1 or below 0. You can also use a saturate node here. Even if you just disconnect all of this and just connect this alpha multiplied with this value to the opacity, it should work fine. The only reason it has this normal and all of that is because it has some refraction here, like a little bit. Because of refraction, you need to provide a normal map. But this is the material we want. So I will just use this one, this M burst. Since this is a blueprint heavy tutorial, I'm just going to use the materials that are already available. So we can go here and just add that in like this. So now we have this effect. So here we have this dynamic parameter. We can scale this in the Niagara system. So here click this and type in dynamic and dynamic parameter, and this is the parameter 1. We can just lerp this or use a curve. I'm just going to lerp this because that is easy. And here for the alpha, we need to change this to like age, and we need to get the particle normalized age. So now we have this effect. If I invert the 1 and the 0, we get this effect. So whichever works for you. Now we can go to the initialize particle, and here we can give a random rotation to this. So sometimes it looks like this, sometimes it looks like that. So this is what we want. And for this single particle, we can move it in front of the camera using a camera offset. So we can give a 20. It will be in front of everything. And we can change this. And here, this is 0.5. So we can change this value like 0.6. Maybe that's a bit too much. 0.5. Okay, that's fine, I think, for now. Now we can try and add this to our blueprint. So go to the AC blink, and here we need to add the system before the delay. So just duplicate this and add our middle system to this one. So this middle system, we can just add this here and like this, and we can add the location. So here this is not the location, it is this location. So now if I press play, now you can see the effect. So it isn't really looking like what we want, but here we can just promote this to a variable, and we can call this Niagara middle system, middle reference, and connect this here and connect this to the delay. And here we can just drag this and type in deactivate. So now let's see how this looks like. It doesn't look that much better. Everything looks a little bit bigger, and the things are kind of going inside the ground. So we need to fix that. So for that, we can go to the middle, and here we have this camera offset. We can just copy paste that to the ring. I will just rename this to the ring also. Now if I just go here and press this, I can increase the camera offset a little bit more, and here I can reduce the size to like 6 and 12, and here I will reduce the size to like 7 and 14. Here we have some issues with our ring, so we can fix this by going into the initialize particle and changing this to random uniform and give a value of 300 and 400. And here we can just go to emitter update and type in spawn rate and set that to like 5. And here we can just untick this and go to the emitter state and change this to like 0.65 and change this value to like 0.1. So we get this effect. So now let's see how it looks like. It doesn't look really good. So now we can change this value to like 0.3 or something like that. Let's see, does that make any difference? Now here we can do some improvements. So first thing, I will just set this color to like 20 for the value. Then I will go here and change the jitter to like 2 and 2. And here I will increase the spawn count to like 500. And this one to like 200. And also we can set the sim target to GPU sim and fix it. And here, if the particle disappears, you can increase the bounce to like 1000 or something like that. And we will do that here also. So I think this looks better. And now we can go into the ring, and here we can just untick the spawn rate and tick the burst again. So it looks like this. And here I will set this to like 0.1. So it's really fast like that. And I can also enable the spawn rate to like 2 or 10. So we get an effect like this. Now for the glow, we need to scale the glow. So in order to do that, we can just go into the confetti and we can get this scaling curve by just copying that and paste it here. We can also paste it here, and we can also do that for our particle here and also our end here. So this looks much better now that we are scaling it. So now if I press play, now we have this effect. So here you can see that the glow is a bit too much. So we need to fix that. So for that, we can go to the particle system and we can go to our glow and initialize and change this to like 0.01, like 0.06. So there is some glow, but not too much. And now click compile. And now we can play this. So now it looks like this. So this is mostly what we want. Now we can go back to our blueprint and do rest of our code and then come back to the Niagara system to add some finishing touches. There are some things to improve that we will do later. So now we can go to the AC blink component, and here we need to hide the skeletal mesh when we blink. So in order to do that, we can drag from here and type in mesh and get mesh, and we can promote this to a variable, and I will call this sk_mesh and connect this here. Now here when we start the blink, we can just drag the sk mesh, drag and type in set visibility and connect this here and connect this propagate to children and connect that there. And now copy this, and after the blink ends, we will bring back the skeletal mesh, so it will be visible again. So here we also need to disable the input of the character when we blink, otherwise the character might be able to move while we blink. We don't really want that. So for that, we can get the character and type in disable input, and here for the player controller, we can get player controller. You can also store this as a variable if you want, and also if you want to make the character invulnerable during the blink, you might have a state manager that tracks the actor's state, like getting damaged, stunned, jumping, running, etc. You can connect that enum here also if you have created an enum to make your character invulnerable during the blink. So that's up to you. Now I'm just going to copy these two, and at the end of the blink, I will just paste this and type in, and here I will just type in enable input and connect the player controller here also. Now if I just press play and press the button, you can see that the character kind of disappears during the effect and reappears. So this is what we want. So here you can do a small delay if you want, so it appears a little bit later, so like this. And one more thing we can do is that we can go to the end effect, and here for this lifetime we can set this to like 0.2 and 0.2. So now let's see. I think this is better. Now here we don't really want to use a delay here because we might not be able to control it that much, and instead of a delay we can use something called a timer. So I will just remove this delay and type in timer by event and drag and promote this to variable, and I will call this blink delay, and now this location I will just drag and promote this to variable, and I will name this teleport location, So this is the location we are going to teleport to or blink to. You can call this blink location. I think that's better. Blink location. And now this location, I can just drag this and connect this here. And for this also, I can just drag and connect this here. And for this target capsule component, I can just duplicate this and I can bring it here. And here I can just drag all of this down. And here we don't really need the blink. We will fix that in the Niagara system later. And we will just type in custom event. And I will call this blink end event. And connect this to the location. So what a timer does is that it will fire this blink end event from this when this delay is over. So a timer is actually better than using a delay. With a delay, we don't really have much control over it. It will just wait for 0.2 seconds and just fire the event. But with a timer, we can just promote this to a variable and I can call this blink timer. And if I compile and if I bring this down, get blink timer, here you can type in timer. So with this timer, here are all the functions you can call with this. You can pause the timer, unpause the timer, is it valid, etc. So you can have all of this control with a timer that you cannot have with a delay. Because during gameplay, we might need to pause the timer for some reason or the other or unpause it, things like that. You need some control over it. So that's why I'm going to use a timer here and not a delay. So now if I just press play, you can see the effect working exactly like that. There is no difference. So now just copy all of this and I will comment blink and I will bring this down like this. Now we can do the line trace part. So for that, here right click and type in custom and we can call this blink trace, drag and type in sphere trace by channel, and here for the star location we can just copy both of these and paste it here, and I can connect this to the start and I can, so we can just get the multiply also. So just copy this and paste and connect this here, then connect this to the end, and here we can just get a branch and connect this here and connect this to the condition and then break this and set this value to like 50 or something like that. So what this does is that it will trace a sphere from the location of the capsule in the forward direction with a distance of this 500 that we have provided. So if I just set the draw debug mode to a variable and if I compile and I can set this to like for duration, and now we can go back to the third person character, and here instead of this blink start we can just disconnect that and here drag and type in call blink trace and just connect the shift and the face button right. This is the B button of the Xbox gamepad. That's what I'm using. So now if I press the B button, you can see a trace of sphere, but it isn't really in the direction that we want. It is just going randomly. Even if I change the analog stick direction, it doesn't really change that. Or WASD, if I just change that, it really doesn't point to the direction we are pressing. So in order to get the direction, we can go back to our component and here we can get from character get movement component. So this movement component and delete that. Now drag and type in get last input vector and then just normalize this value. So the value is between 0 and 1 after we normalize it. So this value, the last input value, is basically similar to these action values And here with normalization, we will just ignore the amplitude and we will just get the direction. So I forgot to do one thing. We need to add these two together. So if I just add the old forward vector to the end, and if I just press play, you can see what this looks like. It doesn't really move anywhere. So here I will just connect this to the distance like this. And now if I press play, so here if I press this and forward, you can see that it is going this way. But here if I press S key and shift, it is pointing in the left direction, not backwards, because the character takes some time to rotate. So that is the issue. And in order to fix that, we can use this get last input vector and normalize that. So if I connect this here and press play, now you can see that the direction instantly updates like this. So this is what we want. And here the sphere trace can be smaller, like 20. I used a sphere trace instead of a line trace because sometimes the objects are really thin. If I use a line trace and if it is blocking the way, it might not hit it, or like a short cube like this. So in order to have a bigger area of detection, I am using a sphere trace, but you can also use a line trace if you want, if that works for you. Now this will point to the direction we want to hit. Now we need to point downwards from that direction. So here, this start location, we can also increase the height a bit by giving 20 here. So now it will be a bit more higher. You can also get the up vector from here and multiply that with the distance. It will be towards the normal of the surface the character is standing on. If you want that kind of increase in height. But here I'm just going to use a simple increase in the C direction. So now here we can do a line trace by channel again. And for start, this start should be the trace end location. So here we need to connect this to the false. If we don't hit anything, we will do another line trace downwards from that location. So it will be at the trace end. So drag this and add like 100 to it. And here. And for the end, we will just duplicate this. And here we need to connect the trace end here. And also trace end here. And this should be like negative 500. So it will draw a line from this direction, this upward direction downwards like this. And now we can connect the draw debug type here also. So we can see what's going on. So if I press play, so here you can see the line trace hitting the ground. And if I hit this, you can see it is hitting the cube like that. And it is going into it. So now we need to see if we can stand. So now here we can just get a branch and connect this here and connect this here again. And we can just break this. And now here we get a location of impact. And if it hits something, we get that. So we can get the blink location and set that to the location of impact. And now we can call this blink start. This is just for preview. We have to do a capsule trace also later. But just to visualize, I will just call the blink start from here. So call blink start. So now if I press play and if I press B, you can see that I am there at that location. And here if I just press this, you can see that since it is going through the wall, it isn't really blinking. But if I go here and press it, you can see I'm blinking at the location. And here there will be some additional issues because it is just a line trace and we don't really know, even if the line trace hit, we can really stand there if there is enough space for our character to stand there. So in order to fix that, we can do a capsule trace. So I will just remove this and here type in capsule trace by channel. You can also use like capsule trace by object if you are just trying for some specific kind of objects like the static actor and you don't really care about other actors, you can do that. But here I'm just going to use a universal way, like a channel. And here for the start and the end, we have this location. So we will just add this with the normal. This will be the surface normal. So if I just multiply this with a float like 100, it will be like 100 units up from the hit location. And here for preview, I will just give a like 90 and 50. And here for radius and half height, we can get that from here. So we can get capsule size. So here we can get this radius. So I will just promote this and I will call the default radius. And here I will also promote this to a variable and I will call this default half height. So we need both of these for the radius and the half height. And here for the radius, we can just bring this in and we can multiply this by 1.2. So the radius is like 20% more than the original radius. So this will prevent the character from getting stuck inside other meshes when we blink. So it is just a safety distance. And for the half height, we can just connect this to the half height like this. And if you have some issues, you can also multiply this with a factor. And for the draw debug, we can just connect our draw debug here. Now if I just press play and press B, you can see the capsule is there. And we only want to spawn to the capsule if we don't hit anything. So if we don't hit anything, we need to call the blink start and set the blink location. And here we can just break this and the blink location is the trace end location. So whenever this trace end, if this capsule haven't collided with anything, we will just set the blink location to this and we will just call the blink. So now if I just press B, you can see that I am blinking to that location. And here I cannot really blink. We will set this up later. But you can blink. But here, if I just press it from here, I'm not blinking. Even if there is distance for me to blink, I won't blink because we are not updating the line trace after we hit something. We are only doing one line trace. We need to do it in a loop and find out where we can stand. So in order to do that, here, so in order to do these loops, we can either use a while loop, but this is kind of scary because we need to set the condition to false for this loop to stop, or this loop will continue infinitely and that can cause like runtime errors. And here, since we have a lot of branches and lot of end states, sometimes we might forget to like set the condition to false and that will cause like runtime errors. So while we can use this is not that safe if we are not careful. So there is another loop which is a little bit more better, and that is the for loop with break. So we have a first index, a last index, and a break. So there are so many ways for us to stop this loop. With this we need to be more careful, and with this we can have a lot of control, and at the end of the day when the last index is done, it will stop. So this is better. So we can connect this here and connect this here. And now here, to find out the last index, this is the amount of capsules we can fit in this distance. So this last index is the number of capsules of this radius we can fit in this distance, this blink distance. So right now it is 500, but we can do some maths to automatically calculate that. So here we are multiplying it by 1.2. So we can just copy that and paste it here. And here I can just promote this to a variable and call this last index. And here, so here we have a radius. What we want is the diameter. Diameter is the total distance from, like, if we have a cylinder, and the distance between the center to the edge is the radius, but the entire distance from this edge to this edge is the diameter. And for the capsule, we want to calculate the diameter and not the radius. But that is really simple. We just multiply the radius by 2 to get the diameter. So here we can just change this to 2.4. So multiply that with 2.4, and then we will get the distance. This is the blink distance. We will just divide it by this one, and we will just bring our last index and connect this here. So this is the last index. So that's working. Now we can get a custom event to break the blink loop. So we can call this break blink loop and connect this here. Now every time we have a fail state here, like this true, this false, and this true, we need to reduce the distance, this blink distance. So in order to do that, I will just disconnect this blink distance. And here I will change this to float again. And here I will call this, and here I will create a new variable, and I will call this temp blink distance. So this is like the temporary blink distance, and this temporary blink distance we can set from here. So this temporary blink distance will be also this, and we can just wrap this inside a function. And now we can call this update blink values or something like that. So if you want to change the blink distance during gameplay, this event begin play only works when we start the game. So if you want to change the values during gameplay, we can just call like blink value update. So one more thing we can do is that we can just drag this. We can just drag and connect this here and connect this here. And we can just cut and paste it here. What this enables us to do is that if we go back to the character, and here if I call update blink values, we can set the new blink distance like this instead of going here and changing blink distance, because this value will only update when we start the game and this begin play fires. But with this update, we can also update it when we want. So now I'm just going to delete that. And here if I select this, we can see that a lot of things are exposed. We don't really want all of these to be exposed. So now we can just do some housekeeping. So go to the AC blink, and here the temporary blink, we can private that. Last index also privated. This one private, this private. The draw debug type, we don't really want to private that because we want that to be exposed. Blink timer, maybe we want it to be exposed or private. Right now I will just private that. Blink location, that's private, and that is being calculated within the component. Blink delay, we don't really want this to be privated. And blink distance, we want to set that also as a character. This is a character reference. We can private that, private this, and private this, and click compile. Now if I go back to the component, you can see. So here now we only have the things we need. Now we can go back here. So now we have the last index. So here if we hit something, we need to subtract the distance and do the trace again. So in order to do that, we can drag in the temporary blink distance. We can subtract the diameter of the capsule component. So we can just select this and collapse this to a function, and we can call this diameter of capsule, and we can make this a pure function. So it looks like this, and we can call this whenever we want. So hit compile and go back. And now here this temporary distance should be temporary distance subtracted by this diameter of capsule, and we will set it like this. And here we can connect this here and connect this here. And now we have this, and we need to add this to this false, this true, etc. So in order to make that easier, we can convert this to a macro, and here we will call this update temp blink distance. So now we can update the blink distance like that, and then just disconnect that and copy that, and now paste it here, and now paste it for the true here. And now if I press play, and now if I press B and press B, you can see that I am stuck at the edge, but there is still issues. So if I am here and if I blink, you can see that it is hitting the other side, which is free, but we are getting blocked by this wall. So let's fix that. So now in order to fix that, we need to disconnect this here and just cut that and paste it here. And here the break blink loop, we can call it here. When we have found a location we can stand on, we will break the blink loop also. If this is false and our capsule trace doesn't hit anything, that means our character can stand there, and that means we don't really have to do this loop again. We can just break that loop. And here, before we call the blink start again, we can get a branch and connect this here, and now just drag and promote this to a variable, and we can ask if the character is blinking or not. So blinking, and we can private that, and this should be default to false. And here if the character is not blinking, so from the false we will just drag and set is blinking, and now we will call the blink start. So we will set this to blinking and we will call this to blink start. If the character is already blinking, we won't be doing any of this, and connect this to the break. And here, if we can stand on a place, but that place capsule trace location is here beyond the wall, if we just go here and in the set world location, instead of sweep, we will just untick that and click teleport and press play. And if I just press the B, you can see that I can move beyond that place. Now after this, we also need to reset the blink. So when the blink is finished, we need to connect this here and set this to false. Now if I press play, and here if I press the B, you can see that I can blink through this because this area is free. That is because I have disabled the sweep. But if I enable the sweep, I cannot blink there. Another issue with the sweep is that if there is an inclined location, if I press it, I cannot really get there because our character will sweep with the ground. And because of that, we don't really want to use the sweep. We want to use the teleport. So now if I just go to the incline and press this one, I can just go to the location where the capsule trace hits. So if you want a longer distance, all you have to do is just increase this height, and here we also need to increase the height here. So increase both of these like that, and now if I just press B, you can see that I am getting to the capsule location like this. So now the issue is that if I just hit here, I don't really want to end up in the other location, but I will just have to blink at the same location. So we need to do that. After this, we will do the blink, pass through, tag, etc. That is a bit different from this. Right now, we are just concentrating on making the character unable to blink through this wall if we don't want to, like this. So in order to do that, we can go here, and if this loop completes without this break loop being called, then we can just copy all of these and paste it here and connect this here. Remember, this blink loop completes when we don't really find a location, and this for loop has done these many loops depending on the last index value. And if that has completed and we still don't have anywhere to blink to, then we can set the blink location to the location of the capsule itself. So get the character and type in get world location of the capsule component and connect this here. And here we also need to reset the temporary blink distance. So set this when the loop completes and set this to the blink distance. So when this break, it will also call this completed, but it won't call this because this blinking bool is already set. So here when we call the break blink loop from this event from the capsule trace, if it is false, we will just set the blink to true and start the blink, and it will also trigger the completed, and we will set the blink distance to the original distance. But if this doesn't get called, then it will run out of this indexes and the loop kind of gets completed, and then we will call this. So and then it will reset the value, but it will also does this. We will set the blink location to the current location of the character, so it is the same location. Then we say we are blinking, and then we will call the blink start. So there was a huge mistake in our system because I forgot to delete this part from our old system, and this was causing issues. So I'm just going to delete that, and I will just connect the blink location here. Now if I just press play, and now if I press B, you can see that I am here. So I cannot go through the wall anymore, and I can blink anywhere. So now let's do the actor tag. So here, if I select this and if I type in tag, I can get this blink pass through tag, and I can cut this so it won't be here, and I can go back to the actor component. So that thing hit the first pair trace. So here, so if this is true and we hit the wall and we get the actor reference, we can type in has tag, and if the actor has this tag, this blink pass through, then we can do a branch here and connect this here and connect this to the condition. And now if this is true, this blink pass through, then we can call the line trace to continue that. If this blink pass through is not in the tag, is not in the actor tag, we will just go back to the normal ways of updating the blink distance and doing the loop again. So here this doesn't have that tag. So if I press play and try to pass through this one, I cannot do that. But if I just paste this blink pass through tag, then I can go through that like this. So here one more thing we can do is that this set world location, we can connect this directly here and disconnect this, and this part we can do before the delay, so it will be a little bit more smoother. So if I just press play now and if I press the B key, it kind of looks like this. And here we are having this camera issues because of camera collision. We will fix that later. But now you can see that I can blink through this, but I cannot blink through this. And now let's make this blink block volume. So if I just select that volume, it has a blink block. but I will just copy this, and now I will just change this to some other like TP block, just to show you I can use any word I want. So if I use that and copy that, and if I go to the actor component, and here that downward trace is from the line trace. So it is from 100 units up to negative 500 units. You can set this value whatever you want. And here I will just make some space like this. And here we have this actor, and we can type in has tag, and I can paste this, and I can get a branch. And if this has this tag, then I made a mistake. I need to connect this here and connect this here. And this TP block, if the actor has this tag, if that is true, then we will just update the blink distance. If not, then we will do the capsule trace. So now if I just press play, and here if I try to blink, I cannot really blink over it or on it. I can blink from it, outside of it, but I cannot blink into it. Like that. So here it will blink at the edges because we are using a line trace. So this one has a different tag. This one has a different tag. So I will just copy this tag here, and I will just paste this. So now you know how to use a tag. So here it will be at the edges because we are just using a small line trace. You can also use a spear trace to give it a bit more thickness if you want. So those are all the important parts. Now we have some camera issues, and we need to set that in the character. But here, if I go here, so here we have this cast to character, but here we have this character camera boom. Here we have this camera do collision test. This is what is causing the issue. If I go here and type in get camera boom or something like that, I cannot really get that. This is a great way to show another feature of an actor component. So that is called event dispatcher. So here this event dispatchers, I can just add a new dispatcher, and I will call this blink start ed, or I will just go ed blink start, and also I will add one more, and I will call this ed blink end. And here when the blink starts, I will just call this event dispatcher like this, and here I will have the blink end. I will call this also when the blink ends. Now compile this, and now go to the third person character, and here if I just select this, I can see ed blink start and ed blink end. I can click ed blink start. We start the blink. We can select the camera boom and type in set collision, do collision test, this to false, and after the blink ends, we can call the same thing. Now we press play and blink in. So it's better now. So when we blink through it, we don't have the camera issue. And one more thing is that if I just select the camera boom, and here we have the camera lag and camera rotation lag. So if I enable them and press play, our blink will be much smoother like this. See, it is kind of really smooth. So you can also set this set camera lag here, like enable, disable, etc. like this if you want. I'm just going to turn it on. You can do whatever you like with these two dispatchers. So that's one more cool thing that you can do. So with this, you can just drag that and call whatever function you want from this. So here with the actor component, you can just drag that in and call whatever function inside it that you want. And also from the actor component, you can call events inside the character. So this is really nice way to communicate between the actor component and the actor. Now you know two ways. Let's go to the character and disable the draw debug trace. So we don't really want to see that. We can also increase the distance a bit to like 700. So now we have this. It's really smooth because of the camera lag. Now we will just polish our Niagara system and also add the beam effect that you saw in the demo. So to add the beam effect, we can go to the NS End YT, and here we can add an emitter, dynamic beam, and here we can click this and add vector, and I will call this beam end location. I will also copy that name. Then I will go to beam setup, and for the beam end I will drag that in, and here I will just tick absolute beam end, and for the color I will just drag this color in like that, and I will set the emitter state to once and loop duration to 0.5 or something like that, and set the lifetime to 0.3. Then we can go back to our component, and here this is the NS end. Here we can drag this, and here we can type in set vector parameter, and we can just copy this and connect this here and connect this here, and here we need to give the parameter. So this is the location of the character but before the blinking. So in order to get that, I will just drag and promote this to a variable, and I will type in old location, and we can get this old location from here. So I'll just drag this in, and I will connect this here and connect this here and connect this here. Now if I press play, and now if I press B, so now our beam is kind of working, but it has some issues. So let's fix that. So now go here and change the lifetime to 0.25. Now change the spawn count to like 20. Let's see how that looks. We can change the loop duration to 0.6 and then set this value to like 0.5. Now let's see. Now this is a bit more faster. Maybe we can set this value to like 1 and this value to like 0.2. I think it was better with 0.5 and 0.3. Let's see. Okay, I think this is better. Now we can do some polishing for the start and the end. So for the start, we can get some stuff from the middle. So here we have this glow. We can copy that and paste that here, and we can drag this color here, and we can also paste that into the end. Now let's see. So these values are a bit too much, so I will set this to like 0.1, and also at the start I will set this to like 0.1. Now go to the end Niagara system, and here we can set the velocity to like 2000, here 1200 and 2000, and here 1 and 1.5, and here for the location I can set this to 12, and here I can go to the emitter stage and set this to like 0.6. So same thing here, 0.6 and go to here, initialize particle, set this to 1.2 and 2. And here we can increase the velocity to like 1000 and 2000. Then here we can increase the number to 100 and here also 100, maybe like 80. And here we can increase the size, and here we can increase the size to 6 and 12. And here maybe it's a bit too much, maybe like 4 and 8. And the black one we can set this to like 6 and 12. So now let's see what this looks like. Now this looks better. So now we can just copy both of these and delete these confettis and paste that. So it is better. And now press play and let's see. I think it's a bit too much for now. So I will just delete these and I will go back and I will set the size to 2 and 6 here. And here for the velocity, I will go from 400 to 2000. Same here. So now we can just copy this to YT start and paste it. And we can just drag our color in. Now let's see if this is working. So the first one isn't really working. So let's fix that. So the start particle system isn't working. So go back to the component. And it's here, YT start. Let's see why it is not working. So this is also at the blink location. This is not what we want. Here we want this location to be our old location. So now if I just try to blink. So now we have this effect. Now we can go back to the end and in the beam we can add a jitter and give a value of 3. Now we can go to the start and here we can delay this by 1 millisecond for each. And one more important thing you have to do is that make sure that all of this is looping only for once, and here in the system updates also, and set this loop duration to 1. Same for all of these. I will just set this to once and 1, and here also once and 1. So it will just complete and finish the emitter. Now if I just press play, now I can blink through this, but I cannot blink onto it like this, but I can blink. I think I want a brighter core for the start location. So I will go here and let's see what we can do. Now maybe we can change this lifetime to 0.2, maybe like 0.4 or 0.5. Let's see. And this one, I will set this loop duration to 0.5 and the lifetime to 0.3 or 0.4. I think that's much better. And here we have this color variable, right? I can just copy this, and here I can go back to the system, and here I can just drag and type in set color parameter, and I can connect this here and connect this here and paste this, and I can just promote this to a variable, and I can call this system color, and I can just copy this, paste this here also. So I can paste it to this here and here, and also I can paste it here. Now if I click compile, so I need to connect this here like this. And now if I press play, and now if I press B, you cannot see anything because it's black, because this color is black. So if you want to set that color, we can go back here and we can set this to like this green color, and let's see what this looks like. It's very bright, so let's fix that. I think I have a little bit more particle than my original one, but you can just set the spawn rate and that will be fixed. So one more thing I want to show you is that how to set the Niagara particle here. So for that, it's really simple. You can just drag this and promote this to a variable, and I will call this ns. So this is a start system, and now click compile, and now you have the start system. You can set this to any system you want. Same thing with the end, with the middle system. So ns middle and ns end, and we have all of that now. So I think that's it for the tutorial, guys. Thank you so much for watching. And if you want to download the project files, you can support me on my Patreon. Thank you.